Hello, and welcome to today's discussion. I signed up at this conference to talk about meetings and conferencing remotely over a conferencing solution. So, specifically, the problem that everyone has had that I hope doesn't affect us today is poor performance in meetings, right? Choppy video, poor audio, constant apologies, or even sending chats from your phone saying, sorry, I'll be right back, right? But what AppNeta by Broadcom software now can do is help you figure out what happened, where it happened, and who can fix it. So I've mined some of the best practices from our customers, as well as included some of the functionality that AppNeta can bring to the table for this problem. So we'll dive into the product in a little bit to actually go through that. So let me start straight away with a user example. This is a rolling 30 days of connectivity from an end user device from a remote employee. Upload capacity at the top, download capacity at the bottom. Monitoring is essentially targeted from that user's machine to a West Coast Azure data center from an East Coast employee. So every dark gray bar here is an ISP drop, primarily. Every light gray bar is the ladder going to sleep. So this was kept open. And this is the reality of hybrid work, right? It is not a continuous connection. And the reality of this kind of idea in hybrid work is that many outside of the largest cities where old municipal infrastructure doesn't quite meet today's standards is going to show up like this, and you're going to have problems intermittently. And I'll be honest, these are actually my stats from March. I can see that most days there's a drop at some point. Anecdotally, I'll say it's usually mid-morning when meetings start, or it's mid-evening, early evening when Netflix does. So you can see that in the middle, we actually have a place in the download chart at the bottom there where my ISP's rate limiting actually failed. And so my normal 100 to 200 megabit connection actually jumped up to almost a gig. So what's the point of this, right? This isn't just work from home. This scenario is, but within user and kind of video conferencing, this is something that users are going to deal with, right? They may be more tolerant or less tolerant to these degradations. And that might depend on where they are, right? If connecting from home, they might expect this kind of performance, but connecting from the office, they'll expect perfect performance. Usually they'll focus on the enterprise network and assume that it's going to work. And regardless, IT is going to be the ones that bear the blame if something goes wrong and be the ones that actually have to go about fixing it or taking it upon their shoulders to figure out what actually went wrong. So for better or worse, meetings are essential to business, right? In part due to the pandemic, but also in part due to necessity. Virtual meetings have kind of become the norm. And even back in the office, they do monopolize most calendars. If you use Google Calendar, and I'm sure that Outlook has the same feature now, you can actually see they've built a tool to show how much time you're spending in meetings every week. And there's actually a lot of studies out there of how to reduce those or how to change those. But I think one core issue is that because we've been remote and we're not quite back to normal, policies haven't changed. And so there aren't a lot of side conversations going on because people aren't in the office. As they go back into the office, those are going to show up again. But depending on the culture, if I can't have that side conversation or talk to you at your desk, then I can chat you, I can email you, or I can book a meeting. And a lot of people have started to do that out of just necessity to kind of capture somebody's attention for at least a small amount of time. But we're at the point where, Gartner thinks only 20% of meetings will be fully in person, right? And these are the studies of showing exactly what's happening to the culture of how meetings are booked and how kind of businesses run. There's actually even studies now around turning off camera and kind of using that to reduce fatigue, right? From a study that we did at AppNeta, we actually found that one of the top issues or complaints or frustrations that remote users had was around video calls and specifically videos freezing, and that being a huge problem for productivity, but also kind of morale when you're back at the office. So there are a couple shifts that I want to talk about here, right? The increase in remote work and popularity is part of that first stat around the number of meetings that will happen. But with this stat, around 40% of workers being remote at least one day a week in the future, that's going to be a huge change to the way that we do meetings. And statistically, this means a large number of people likely are going to be fully remote, and a smaller number is going to be fully in the office, or rather, a larger number is going to be fully in the office. The flexibility is going to be the key theme. And many were remote during the pandemic. We got used to potentially doing a little bit more on meetings and a little bit more dependent and maybe reliant on video conferencing tools that were available. And so as the shift towards hybrid work or back to the office happens, we're going to have to look at policies, right? People are used to video conferencing and the benefits that it really affords, right? It can be less disruptive than physically moving to a new space in the office. Often with your computer in hand, you've got to connect up to the hardware in the meeting room. And then if you're actually meeting with people who are in your office and out, you're going to have to do conferencing anyway. So you're going to have to combine the two. Right? Video conferencing isn't new, right? We've seen this kind of huge kind of boom with Zoom. And that's really the shift towards cloud hosted. Polycom and WebEx back in the 90s, Skype in the 2000s, right? Like this has been around for a while, but now we're really seeing, because of Zoom, it's become a verb. It's become something even my parents know about, in the sense that it is now so common and something that we have to work around, and Zoom, I think, really heralded the shift towards a lot of cloud hosted. We saw, the Skype for Business shift and the Skype shift to Teams. And we saw a lot of changes when that went through. And obviously, Microsoft has a huge market share when it comes to voice and video. So I think the distributed user base of the pandemic has made it almost a necessity that we need to worry about the cloud hosting and kind of a centralized location for a lot of these voice and video communications. And the last piece here that I wanted to mention was performance. And it's something I'm going to hit on a few times, but performance is going to be variable, right? Depending on the region, user habits, if they're on Wi-Fi or wired connectivity in office or at home, right? Microsoft and others will guarantee a certain amount of uptime, usually 3 to 5 nines, as part of the service level agreement. However, anyone who's leveraged Teams or other solutions, that it can't really fully capture the performance of a system, right? It has to be an end-to-end measure. It has to measure from the user perspective, because without that, uptime is certainly an interesting metric, but apps don't really go down anymore. They just get slow. And a lot of the reason they get slow is not due to Microsoft's fault, but it could be the ISPs in the middle. It could be the user environment. And we know that understanding performance is difficult. So let me walk you through a little example to show you a little bit how we're kind of addressing this problem. So as an example, Microsoft Teams, the architecture is kind of by design a black box, right? Microsoft does a good job at running this, and the architecture is really well thought out, but they've taken a number of steps and kind of conscious effort to limit your ability to directly monitor the performance, right? And the availability of Teams from the employee's perspective, because they're running an application and they want to make sure it's, as performant for the masses and for everyone as possible. So we work extensively with Microsoft at AppNeta and their customers in monitoring Teams' performance themselves. There are a few things to understand about the impact the performance of Teams has for your employees. Right? There are currently around, I think, just under 40 regions around the globe that hosts Teams calls. Right? There are more actual Azure locations, but only a subset of those actually host Teams calls. And the one that is geographically closest to the organizer of the call will be the host region. So you see in the middle there, the host region is actually in this case, in Vancouver on our map here. Right? All other users will connect to the Azure region geographically closest to them. And then once connected to that point of presence, the Teams traffic will actually transit over the Azure backbone to the host region. So as you might expect, Microsoft runs a very high performance backbone for that between the Azure regions. But the determination of which region each user connects to is going to be handled by their global network of Anycast DNS, which works well. A challenge is that they've also have a specific Anycast address that they provide customers as monitoring or testing the performance. But the issue there is that it's one global Anycast address. So when you target that for performance, you're going to get the closest region to you, geographically closest, the ones that are marked Azure Region Relay here, you're not going to get specifically the one where calls are hosted. And so we have multiple calls per day. The host region could move around based on the organizers of that call. And every time you test, you're still going to be testing to the same Azure region. So AppNeta is actually planned for this, and we actually have a global network of targets, global monitoring targets, that are deployed in the Azure regions that host teams. And this enables you to specifically target the region or regions that are hosting the calls based on your company's locations or based on the organizers there. And as our target is running our monitoring point software, it also allows us to do an upload and download view. So we can do a bidirectional view of traffic and performance instead of just, kind of pinging off the outer edge there. And the setup tests kind of the complete end-to-end application delivery path between the user over their local Wi-Fi or their LAN connection through their WAN connection, and then all the way to the Azure region over their ISP. And it allows us to give you kind of complete visibility to find and fix problems no matter where they are in the application delivery chain. So with a globally distributed service like Teams, not every user experience is going to be the same. So this architecture affects us in the office as well as at home. So if I look at the office, a predominant trend that we've been hearing is actually a reluctance to use meeting rooms now that people are back in the office, either because of pandemic policies that are still in place, limiting number of people in certain rooms or certain areas, or maybe a number of people in an office per day. But it also could be that employees are kind of used to multitasking, right? When's the last time you were in a meeting and you were 100% focused on that meeting? You might not be 100% focused right now, but that leads to the usage kind of above and beyond the expected pre-pandemic needs for enterprise networks. And let me explain that a little bit. If you have more people in the office, but instead of going to meeting rooms, they're taking that call from their desk, you now have simultaneous calls that are actually using full round trips in and out, right? There's no peer-to-peer kind of relationship with a lot of these voice and video conferencing systems. They're all relay based, going up to the cloud and back. And so you're having more of those streams on the same network that may or may not be kind of overwhelming or at least causing more impact on the network. So prior to the pandemic, right, during the kind of the pre-times, many of businesses were using kind of direct to internet access for this and right sizing based on office populations and kind of the expected amount of traffic. But I will say that networks aren't exactly falling over because of this. But the change in behavior is one that IT will have to monitor and really understand and change policies as they're able to, right? And this actually supported by a couple Gartner statistics is talking about reduction in spend on office meeting room related devices and technology. Okay, at home, you're dealing with different connectivity challenges, right? Either the ISP links are under provisioned for the home or often asymmetric, which is fine for Netflix because of the download priority. But for apps that use both upload and download, the most basic plans from most ISPs are just kind of barely sufficient, with 1 to 2 to 3 megabits per second upload. So as soon as you have multiple streams or multiple things going on in the home, you can start running into issues. In fact, our own IT ran a bit of a survey to start the pandemic to understand what people were paying for or kind of the expecting from their ISPs so that our IT could actually provide better advice if they need to change something or at least understand what was happening when a problem was reported. Right. Many enterprises we've talked to are actually now creating policies around requiring wired connections. Right. We're still using a trust but verify approach. So AppNeta can actually show you the connectivity for a specific user or a path that will allow you to say if they're on VPN or not, if they're connected via wireless or Wi-Fi, and then if they're connected for wired. And so monitoring that connection and actually looking at the status as it changes over time can be really, really important. So we've talked a little bit about the shift that we're facing and the challenges, but let's get to some of the fun stuff, right? Let's talk about solutions, some metrics, how we can troubleshoot these issues and dive into a little bit of product after that. So when we're thinking about performance and monitoring, there are a couple of angles that we can approach from, right? Traditional monitoring in the top left via infrastructure monitoring. On the pro side, right? Own devices are fully observed. If there's something down, it's pretty obvious. We can most often fairly easy to resolve if that's the case. With more and more of these apps that we're using being cloud delivered, we have less and less visibility into those. So infrastructure is only going to give you visibility into those own devices, LAN, or maybe data center environments. Every piece of connective tissue in between is going to be a black box. And so infrastructure monitoring is great for what it can do, but it does need to be supplemented by different visibility. If we go clockwise here, cloud platform performance, right? Typically, these are run well. As we mentioned with Microsoft Teams, resilience, redundancy runs pretty deep in the cloud, especially for the top apps. But you're only going to get so much visibility there, right? As we mentioned with Teams, you're going to get uptime and a guarantee there. But that just means servers and kind of availability. It doesn't mean that your users can actually access those services. That's going to rely on much more of the connective tissue, much more of the connecting networks between, right? Voice metrics, CDRs, great for actual calls, can be excellent for troubleshooting reactively once an issue has occurred, but there's no way to be proactive or to understand when performance is trending in the wrong direction unless there are, kind of active meetings going on. And so you have to wait for user impact before you can actually take any productive steps. And the last one here is WAN performance, right? This piece is pretty crucial for cloud and web apps that are delivered via that WAN, because it's not only one of the largest components, right, of the different hops that are available, the different networks that are included, but it's often the most dynamic, right? And I think I'll put an asterisk on that. The cloud is also very dynamic, especially if you're going into one of the largest cloud providers. But you do need active monitoring to get this information. Otherwise, again, you're relying on a picture at maybe specific egress or ingress points, and you have to kind of piece together the end-to-end path or look at the metrics in between. If there is a spike in one of the metrics in between, you don't actually know where it's happening. You just know it's somewhere in the middle. And so as we're looking at mainly cloud-hosted conferencing solutions or voice and video solutions, let's look at some of the top considerations when it comes to performance. All right. So I want to start with a summary. There are kind of a number of techniques that we've used and we've kind of worked with our customers to understand and kind of revise when we want to understand the scope of when issues occur. And kind of from our experience, the top considerations were really around what ability do you have to see bandwidth and capacity? Can you identify transit quality? And what analytics do you have available around end user experience? So if I start with bandwidth, here's a few things to look out for that I have just kind of listed. In the enterprise network, we need to assess how the paths have changed, right? For the new cloud hosted models, where does the traffic exit the network, right? What are the new internet kind of access points that are needed as far as to understand the performance and kind of end-to-end bandwidth or capacity that's available? I did make that mention about employees using meeting rooms. So how do we actually estimate concurrent usage now, right, for each facility? And as we kind of aggregate or use different technologies to bring traffic together, maybe for security purposes, how do we actually know what the new weight of the network is going to be? And right, sizing that internet access and determining, performance through firewalls is going to be an important test, especially as people return to the office. Managing competition with other applications, right? We know that applications have changed over the past couple of years as far as different departments adopting new, maybe SaaS and cloud apps, or maybe just kind of retiring legacy apps that they couldn't access or weren't easily accessible in the past. So we need to look at kind of what are the new applications on the network as well. If you're using VPNs, you've probably already done VPN concentrator upgrades and looked at overload. But just as we kind of think how the traffic is going to be flowing in the future, let's look at our VPN stats and figure out if we have enough to support those in some of the offices. And then finally, from the work from home perspective, I think there is competition for bandwidth when it comes to Wi-Fi on residential ISPs. So just a little bit of a mention on that while we're talking about bandwidth. So transit quality, this is all about managing end user experience, right? Measuring what is known good values of loss, latency, jitter, all the metrics that we want to know, And then if we look at it from the enterprise perspective, we can talk about maybe verify if QoS is working properly within the enterprise, right? Marking inbound traffic, prioritizing outbound. We can talk about things that we can change there to make sure that, one, it's ready for voice and video performance, but also we're reevaluating as the hybrid work really sets in. In the enterprise environment, we also want to reduce competition from other data applications, maybe if they're more prone to bursts or more prone to specific times of day. We want to look at that, maybe moving schedules around. And then we want to look at loss created by any firewall traversal or other security that's been implemented in the enterprise environment. For the internet paths, especially to Teams access points or Teams connection, Teams being kind of my representative example for any voice video right now, we want to look at how many ISPs are actually in the path, right? We want to limit the number of handoffs or peering points in the transit. It's going to increase performance and it's going to have better stability if we have fewer players involved. So looking at the end-to-end path and really understanding that is going to be very important to either selecting or kind of maybe reselecting which provider you're actually using. Obviously, you can consider tools like MPLS, bringing in SD-WAN to try to make some of that a little bit better or more performant. There are different kind of components to that, and you may have to do different breakouts if you want to really kind of optimize performance for voice and video. And then for transit quality in home, always looking at Wi-Fi performance. We're looking at, making sure that people are probably hardwired. If they have to do, power line extenders or power line Ethernet or something like that in the house, like really anything to get it wired versus Wi-Fi is going to be a lifesaver for IT, just because users tend to move around, and wired connections will keep them in one spot, but it will also provide better performance. And I think also look at the quality of the ISPs that are available, especially if you have regions that specifically may not have as good internet. We want to make sure that we are aware of those and also ensure that we're looking at those when we're looking at tickets and trying to troubleshoot the issues. So last one here, analytics. We want to manage the quality of experience over time. This is about getting really a consistent set of data on path quality, capacity loss, jitter, latency. But the last one, the piece I want to harp on, is really around the locations or the regionality. So many of us work in different geographies, right? We work with teams spread over the world. And that means kind of varying connectivity profiles, but also varying performance. And in order to determine the kind of appropriate thresholds and measure actual paths against that standard, we want to be a little bit careful. So, the biggest thing we think about is how do we actually manage quality for users going directly from work from home to Teams versus in the office going to Teams. And, is that totally out of our control? No, not really, right? We can instrument our office and measure office to cloud performance, specifically from the office, not maybe from the user just yet. And this path is really under control, right? We have well-known networks and providers. We can look at kind of what the representative performance for office-based users are, and also kind of what they're accustomed to, and understand really what's driving the performance in the office. And we can use thresholds in the office to actually flag problems that are maybe worse than average, right? So understanding what performance looks like in the office also gives us a baseline to compare what users have in a work from home environment, right? The thresholds are probably going to be different here, and we'll determine which users are kind of seeing good or poor performance. So that'll help understand if they're better or lower than the norm. Individual user challenges can be debugged, but let's focus on getting higher regions, higher kind of visibility before we start focusing on kind of the one-to-many approach of actually going for IT to troubleshoot each users, right? We want to find out if representative, if the office is representative performance, are they at least within a certain standard deviation or certain mean, right? There's going to be some issues with troubleshooting where we want to look at the different geographies to understand if an issue is present. Maybe a user is reporting an issue. Is it something that is overarching? Is everyone having a problem and therefore it could be on the app side? Or potentially, is there a common geography that is a problem? We'll actually dive into that in the demo a little bit later. Is there a common data center? Are they all going to the same region? right? Or is there a common last mile provider? So is there a regional outage for an ISP or a regional problem versus a larger problem that's going to affect more users? And that will really help isolate the scope and get it down to whether or not it's a regional problem or an individual problem, right? And so that helps you quickly identify the size of the group affected. And it also allows you to start looking at the idea of doing a hop by hop analysis. So if we talk about that, one of the ways that we've talked about that in the past and with our customers is that once you understand a little bit about the scope of a problem and identified maybe an issue is location specific, a valuable approach that we've found is to kind of attempt to isolate the problem to one of these 4 error domains, right? If you can identify the area where the issue is originating, troubleshooting is just much simpler, right? So the actual steps used in resolution are going to vary dramatically based on the level of access or control you have over these different areas. But in the case for potentially work from home users, in this case, there are 4 kind of macro level error domains. And I think the one on the left, remote network, could very easily be an office network as much as it can be a work from home network. And you're still going to have the same problems. Wired or Wi-Fi, where are they? Are they close to an access point? Is the signal strength good? Are they switching BSSIDs? Like, how are they actually connected? That's all important information. But it's actually going to be pretty clear from the data that an issue with maybe a service, in this case, of voice and video, maybe it's going over common infrastructure, or maybe we can actually isolate it to an access point. Right. So if it is in the remote network or the kind of, in this case, the office work from home, or really just the local area network, we can do a lot in that network. The places where we can't do a lot are in the last mile ISP, right? If that's the user's ISP, we don't actually know what they're getting for residential internet. Is it symmetric? Is it, sufficient enough? Are they on wireless, wired? All those things are things we need to actually figure out in the user environment. For the last mile ISP environment, we just want to focus on who it is and if there are any kind of local issues. And so we can do that pretty easily by using active monitoring over the end-to-end path. So transit backbone being the next one, right? End-to-end visibility is really, really important here, but peering and things like that, using BGP AS resolution will allow us to figure out who's the peer, where's the traffic going from when it goes from the last mile ISP to the transit, and then eventually to the application service provider environment. So as we do this, the way that AppNeta gets this data is through an active testing methodology. Because the route in use is going to be dynamic, especially in this kind of scenario, it's outside your control. You do have to measure it continuously and make sure that you can see when it changes, right? Does that route flapping or change exist at the same time of a problem or an issue? And finally here, we use a low overhead approach, so you can continuously use this and have this running all the time, so that you don't have to wait for kind of a network problem to actually appear. So one of the things that we hear is like common tools like iPerf, speed tests, and even kind of other application performance testing products will work on this, but they typically rely on some kind of flooding. Right? It's going to disrupt actually the critical applications that you're trying to monitor. And so that's not really acceptable in a production environment. So the patented technology that AppNeta uses is extremely low overhead and doesn't actually impact it. And some of the metrics we can get from that, I want to talk about now. So when AppNeta first started, we focused really first on real-time apps. And that's, what we're talking on here today, because they are harder. Right? Data via TCP is going to be pretty fault tolerant. Data and voice packets actually behave pretty differently, right? We have voice packets that are smaller, they're prioritized differently. We have a very big aversion to lost packets in this case. But we actually put real voice packets, including the SIP stream, out on the network to understand both data plane and control plane, how the network reacts to this traffic, right? There are different thresholds that we need in order to understand good versus bad performance. But with this data, we can actually take matters into our own hands and ensure that we have kind of the right connectivity and infrastructure between us and our voice and video provider. right? So here, I just want to mention sufficient capacity, right? We want to look at the end-to-end achievable bandwidth, not just the bandwidth at any one point. And this will be able to tell us essentially if we can actually get a call all the way across, right? The bottleneck somewhere along the way is going to be the part that actually distinguishes what is good performance or what is bad performance. I mentioned two-way latency. It's best if we can get bidirectional, right? Get that upload and download. Very important for these types of meetings, just so we don't have disruptions. And then voice specific loss and jitter are going to be really important because that voice specific nature allows us to use those smaller packets. It allows us to look at it a slightly different way and see how the network reacts specifically to those packets, right? There is kind of another one here that I didn't list, and that's the value of mean opinion score. Some people love it, some people hate it, but one of the nice parts about mean opinion score is that it can provide a baseline and it allows you to compare not only over time, but across geographies. So when it comes to voice performance, understanding what's good loss, what's good jitter, latency, it can be difficult across a global footprint. But if we set alert thresholds for reporting on mean opinion score, it actually creates a nice uniform metric that we can follow on, right? So like, if we look at, cell specific, right, we're starting in that 0 to 4 or 0 to 5, and we can look at what is good performance for that region and then see deviations from there. So one of the things you'll notice from the video conferencing scenario is that traditional monitoring can only passively pull the metrics from really one location, right? That remote network, that local area environment. Likely it's going to be SNMP host information, some connectivity metrics, outside, CPU issues and traffic congestion on an interface. There's not much you can troubleshoot when it comes to voice and video conferencing, right? Especially when tickets come in kind of hours after the actual event, right? CDRs can be available, but generally only gets the VoIP portion. And more importantly, it kind of requires users to be impacted before you can detect issues. So two of the biggest requests that we've heard from our enterprise customers over the past kind of year or 2 years is really, how can I gain end-to-end visibility into network and app environments I have no control over, which is really the genesis for this talk. And then how can I diagnose performance issues? And this is really around speeding up resolution, right? We talk about mean time to resolution or mean time to innocence, proving it's the network or proving it's not the network, depending on your visibility. Very important for being able to limit the time you actually spend troubleshooting tickets. And the key here for us is active monitoring. It has to be active monitoring. When you can monitor continuously, right, you're able to be more proactive because of the way you approach end user experience, right? Namely, you can see when performance is degrading, not just when it's already impacted a user, right? There's always kind of a fine line between alerting early and getting noise versus alerting late and getting kind of blamed for performance. So what's better is understanding that a certain percentage of users within a region are having an issue and allowing you to report on that kind of tooling to provide you the information, say, oh, I want to be alerted when 20% of users in a region have an issue, right? And creating some rules around that so that you're not jumping at every single kind of alert that pops up, but you're also not so late into the game that you're already getting multiple tickets for the same issue, right? Returning to those error domains, right, at the top there, we need different approaches to fully isolate where an issue is, right? In the remote network, host, wireless, wired connectivity often requires either pulling SNMP data or getting an agent on the machine. That can be, automated, but it can also be maybe a representative user group instead of all users to start. Network delivery path, really, that's going to require, again, an agent on the machine or one side, maybe in the office environment. Transit, that's where we're really going to need a lot of the kind of active monitoring, because otherwise you're only going to get kind of generic outside in views that could be impacting users, but you don't actually know if it's impacting users until you go and see an actual path along that line. And with cloud, really, it depends on the app, right? Internal, you can instrument kind of infrastructure. If you've moved an application to the cloud, you can put instrumentation there. If it's external, you really do have to have active monitoring in order to get that response from the outside. All right, so let's dive into the data and some of the insights that AppNeta can provide and bring to apps like Teams in this example. I'll start by highlighting a few sections, and then we'll kind of look at the live demo environment and come back to that specific use case. So this is an AppNeta application quality dashboard. This is specifically a Teams dashboard, and you can see we have it split out into green, black, and red. Green being the time where the service was good, black being where the service had actual outages, and then red where it's violating our alert profiles or really the SLA for performance, right? Again, Microsoft does a pretty good job of running Teams. So no outages are reported here, but that doesn't mean that users aren't having problems. Right, the report breaks down by location at the bottom and sorts by worst offending locations, allowing you to prioritize your work. And in this case, a large portion of the violation is actually from the Atlanta office. And so we can immediately identify that that's an office we need to go look at and identify what's going wrong there. And it may actually be that all the other offices are fine, right? But this is one way that we can look at kind of baselining performance of apps like Teams by looking at the service quality. And I think the key to this is that location-based component, because we know that performance is going to vary location to location. So most troubleshooting will start with the app, as we just did. But from alerts or tickets, you'll know an app, a location, or a user is having trouble. You may not have much more information than that. So the first thing we recommend diving into is the actual route and the route diagram. And it's something that we can show very uniquely. This helps us isolate where in the delivery path an issue might be occurring, right? It allows us to look at the path over time and over a range of time. So this one you can see is flipping between an hour view and showing you how the route changes over time just by going. So you will have multiple routes into specifically cloud apps over the course of this hour. If you limit it down to 10 minutes, you're going to see a few less routes, but at the same time, you're going to see multiple in there because it is a dynamic network, right? And this will basically show us if route changes or flapping exists, or if a route change actually preceded an event, right? It tells you what network operators and owners you're dealing with that BGP AS resolution. Right. When we talk about continuous monitoring, I just want to talk about TruePath for a second. TruePath is our end-to-end proprietary active network technology. It allows us to basically send out packets, 30 to 50 packets per minute, every minute across the network in order to understand the end-to-end visibility and end-to-end metrics on that path. If we detect an issue that basically goes above an alert threshold, it's going to auto-escalate and confirm that that issue is persisting and is not just maybe caught in a route change and slow. Once it auto-escalates and confirms the issue, it's actually going to kick off a diagnostic. And we'll get to that in a few moments. One of the things about our solution is that it's network agnostic, right? It's from the end user perspective, from the offices or locations or even user machines that are accessing the applications you care about. And we're looking from that source to a target. In this case, voice and video performance. Specifically, we have a great relationship with Teams here. But that's going to include if they're going over wired or wireless connectivity, right? It's going to tell you something. And I mentioned before, we actually call out specific connectivity to understand if someone has moved from wired to wireless or something like that. And finally, it's going to add data and voice traffic. So I mentioned again a little bit before, video conferencing is made up of both. And so we want to be able to monitor both and see how the network reacts to those and see if it reacts differently. So let's talk about the diagnostic insight real quick, and then we'll dive into the product. So when TruePath actually auto-escalates based on that alert profile and confirms the issue that's persisting, it's going to kick off an automatic diagnostic that can also be manually triggered, but this gives you a hop-by-hop insight into the path at the time that the issue occurred. It's not retroactive. It's not later in the day. It is actually when the issue occurs, we're going to give you this data. So by the time IT gets alerted, we're already gathering more data for you to look at. And this is, maybe not later when things could have returned to normal. So you can isolate specific hops here, or really you want to draw lines between those different error domains. So if you look, carefully here, you can see where the LAN environment is, where the ISP environment is, and then where the actual, in this case, Office 365 or kind of the other Microsoft environment is. But it allows us to look at a bunch of different metrics I mentioned earlier. Here you can look at loss. We can look at maybe where MTU drops along the path. If you have QS set, it'll also show what the setting was and if it was honored on each hop along the way. All right, so let's look at a specific piece here. I'm going to log in on this side here, and I'll flip it up to the top screen. All right, so let me explain this page really quickly. So at the top, we basically have the filtering. We have the ability to sort and filter off a number of different things, including, in this case, the type of monitoring point. In this case, we're looking at Windows PCs. We're looking at a specific set of monitoring points. So in this case, Denver, Colorado, as well as San Francisco and Vancouver. And we're looking at a specific target, and that's one of our GMTs, are basically our global monitoring target within Azure. So you can see there's 3 different lines here. We basically have the San Francisco line. If I hover over the San Francisco route where there's only one, you can see the whole route. I also have the Denver link, which is actually from 2 different devices, one on an end user machine, and then one that's a freestanding desktop device that we typically deploy in smaller offices. And then we also have the Vancouver link. So if I scroll down really quickly, I can see one, we've also grouped by the monitoring point name. Essentially, in this case, we're grouping by location. But what I can do is, as I scrub through time, so this is a 10-minute window for an event that happened a while back. If I actually scroll past here, you'll see right around here, we actually lose one of the links. And if I highlight these specific incomplete routes, the ones that actually failed, you'll see it's coming from the Denver environment in 2 different directions, right? One from the user device and one from the actual desktop device. And so we can look at what's actually breaking, where it broke, and we can see precisely where it broke down. So you can see this is in case actually went through the Microsoft network. If I switch to the network view, we can see the Microsoft network actually was what was reached in this case. So it actually reached all the way. And then on the other side, we actually had one breakdown in the end user environment. And so I've already isolated where some of the issues are occurring, but what I haven't really done yet is isolated specifically what's happening here. So one of the things I can tell is that San Francisco and Vancouver are not really the problem. So I can immediately just get rid of those. And now I can look specifically at the Denver environment, right? That limits me down to 2 different options here. I can see generally we're okay in both, but I can see that I have violations on this path. And this is the path I really want to focus on here. So if I click through to that, what we can do is we can actually look at all of the end-to-end metrics for this path, right? And so I have a good example here. I actually have probably a better example of the actual path. So let me switch over to that in just a second. So this one is going to show us a 4-day view instead of a shorter kind of 10-minute view of essentially what happened here. And I know this because I've actually talked with the user, is that he has multiple ISP connections. And so this is actually a backup or a failover event where his internet broke down for the primary and he switched over to the backup. So I can see one, the capacity is roughly unchanged. I mean, he's paying for roughly the same amount, but we're going to see the spike in utilized capacity as the other backup is not as strong. And as we go down, we can actually see for the rest of that day, he had a large amount of jitter. Round trip time was affected, but latency wasn't. So latency being essentially that outbound connection, round trip time being the return connection, plus the outbound. But what we can really see is when we get to the voice specific stats, it's very clear that we have a problem with both the jitter. We saw that in the data side, but also it's affecting mean opinion score. And so this is what actually triggered the event, is he could see that while he was on conferencing, he was having trouble getting good performance. And then what this allows us to do is really confirm that this is an issue for this user. And so what it allows us to do is, if I know that this user is the one that has the problem, I can switch over to our usage portion and look at the passive monitoring. So in this case, I've actually jumped time. So I'm more of a current view here, but I can look at the fact that I have multiple different apps that are running, as well as the different offices that are running them. So I can look at those basically by location or across location, and I can also look at category and classification. So I can see what are the kind of the largest apps that are running here. So if I filter on the Denver environment, I can look and see that Microsoft Office is the largest amount of packets being sent back and forth, flows. I can look at network application latency differences. And really for applications, I can look at retransmits. I can look at TCP retransmits and figure out where maybe some of this performance issue is shown. And now we're switching to a more kind of modern, or basically within this week view. So we're going to see sort of normal performance, although 10% retransmits is quite high. So he might have already switched to the backup link there. But what this really allows us to do is not only isolate from the network timeline view, isolate the specific user that was having a problem. We can look at the link, we can look at the path, we can identify where the issue is, and then we can switch over and find out if there are other apps that are the problem, or perhaps it's the connectivity. You can see here this little icon on the left is showing that it's a wired connection. If he switches that off to a Wi-Fi connection, we can actually look at that as well. So there are a bunch of different options we can do there. We can also look into experience. So we have web paths. This is where we look at our web synthetics. Again, this is our demo environment, so I have a number of them here. But if I, again, filter to monitoring point name and then switch to that Denver, Colorado, I can see specific links that we have sent out to a number of different solutions, including Zscaler, over Zscaler to things like Office 365. If I click on one of these, basically allows me to see the full view of the waterfall charts, everything that's going to be happening with that application, AppDex score, and also DNS. So DNS being very important. If we have multiple DNS servers configured, we can actually look not only at the fastest responding DNS, but also other DNS resolutions to look if maybe we have a load balancing scenario with multiple DNS solutions and we want to make sure that one isn't being hidden that is having trouble by another load balanced DNS server that's actually resolving fine. And so with that, I think I'll switch back here. I'm going to end a little bit earlier. I think if there's time for questions, I'm happy to take them. If you missed our POC this morning, we have the demo available in the booth, along with some of the links to both AppNeta and NetOps, as well as the combined story as we move forward and start to integrate all of the data sets and the way that we look at networks. I think we also have a very short survey if you're interested in the chat, as well as in our booth, to get a $5 Starbucks gift card. But here, happy to take questions here or in the booth. Thank you for joining today. I'll probably shut this down.